Hello everyone, welcome to another video. So this will be our key skill 1 for vectors. Now this is absolutely crucial because this hinges on the entire concept of vectors. So if you get this right, more or less the chapter is over already. Okay, so we're going to start with looking at how to multiply a vector with a number. And then following, we're going to do how to add and subtract vectors. So how to do it and how it visually looks like. Yeah, so actually this is quite simple. If you look at this one, for example, so AB is minus 3, 4. So you can see that we say that PQ is 2 times AB. So literally you just take AB, this vector, you times 2, see? So 2 times the AB. So what you do is this 2 will multiply both the numbers in the vector. So that's why it becomes minus 6 and 8. So it's 2 times this, 2 times this. That's it. So when you multiply a number into a vector, it's just like matrix. The number multiplied by every single number inside the vector. So visually, what happens is like this. So imagine AB is like this direction. So PQ will be the same direction but longer, double the length because it's times 2. So you can notice that if I go and calculate the magnitude, so of this magnitude is over here 3 square plus 4 square. Actually it's minus 3 square, but it's the same. So over here our PQ is minus 6 and 8, right? So actually the magnitude is minus 6 square plus 8 square. You notice that the magnitude is 5 and 10. So the magnitude doubles also. So that's the effect of multiplying a vector by a certain number. Okay, so the next thing we're going to do is we're going to add and subtract vectors. Now in vectors, usually we just want to add. We do not want to subtract. Okay, but more on that later. So how do we actually do this? So for example, we have something like this here. This minus this plus this. So literally, it's just all the x components do together. So if times in is 2 minus 3 plus minus 2, and that's why it's 3, so it's over here. And the number below, which is the y value, you do the exact same thing. So it's 6 minus 4 plus 1. So see over here, and that's it. So adding and subtraction and it's actually very simple. Now visually it becomes a bit more complicated. For visual sake, we tend to not want to subtract because subtracting a vector is pretty hard to visualize. We like to write it as addition. So using this example again, you can see that this is a minus this vector. Now we do not want to have minus because it's hard to understand minus. So we change it to plus. And then to compensate these two numbers, we will negative. That's why it becomes like this. See, from minus to plus, from minus 3 and negative to become 3, 4 and negative to become minus 4. So I write everything as this plus this plus this. So adding is a lot easier to understand what it does. So let's I start from here. So imagine we start at this point A. Okay. So what we do is we need to do 2 units, 6 units, right? Because it's times 2, right? So it's 2, 6. So what 2, 6 means is you move to the right 2 units, you move up 6 units. So just imagine you start at A, 1 square is 1 unit, 1 square is 1 unit. So 2 units and go up 1, 2, 3, 4, 5, 6. And then you end up at B. So after you add this from the starting point, you end up at B. And then you add another 3 minus 4. So 3 minus 4 means 1, 2, 3. Then minus 4, I go down, right? So it's 1, 2, 3, 4. You end up at C. Then after that, you carry on, you add another minus 2 and 1. So minus 2 and 1 is left 2, up 1. You end up at D. So D is the final destination. Now the question is, where is the answer? Because the answer is 3, 3, right? So from the start to the end, effectively you are just moving 3 units and 3 units. That's why the 3, 3 is here. From the start to the end is A and D, right? So from A is 1, 2, 3. Then I go up 1, 2, 3. I end up at D. So after all this long story, the effective distance we covered is just 3, 3. That's why the answer is 3, 3. Because that is the effective distance that we move from the first point to the last point. And that is why this answer 3, 3 is what we call a translation. We are just moving a point from the starting to the end. Okay, so this effect of adding is basically you're just transferring the point. And then this vector, the answer, this 3, we just call it the resultant vector because it's the final actual net distance that you have moved from the start to the end. So see, that's what it means. So this covers the basic concept of vectors. So hope you have learned something. Thank you and bye-bye.